The purpose of this introduction is to introduce you to the watchdog timer as used by the 64, as implemented by the 84 alpha PIC microcontroller. What is the watchdog timer? Well, just simply a timer that can be used in several different ways. It can be used as a simple timer. If the watchdog timer is enabled, if the program gets lost, the watchdog timer will time out and the system will reset. So if the program gets lost, it goes into, or if it goes into system runaway or freezes, well, after the watchdog timer expires, it'll reset and it'll send the program to the reset vector, which is 0x000. So you roughly calculate the worst case program runtime, add in a 20% safety factor, sets the watchdog timer to some value close to that. Suppose time was 200 milliseconds, if nothing happens during that time, then it'll reset. If the system acts correctly, the watchdog timer needs to reset before it overflows. This is done by the clear watchdog timer. So basically, the clear watchdog timer will reset it before it overflows, so it never causes it to go back to the reset vector. So these are instructions that you would put inside of your program so that as long as the program is acting normally, it'll execute these clear watchdog WTs every once in a while and will cause it to keep from allowing the watchdog timer to reset. However, if the program gets lost, then it won't ever get these cleared up watchdog WTs and it will reset. Another major use of watchdog timer is if you're using portable power like a battery and you're concerned about limiting power consumption. Say a task takes 100 milliseconds to complete, so one way to do this would every 100 milliseconds the job gets repeated and energy consumption is continuous. Not only that, you don't have any time to do anything else. This is not good. However, suppose you're monitoring something that is slow to change, perhaps every minute. The controller would either work on other things or would hibernate and wake up every minute, take a look around, see if there's been any change. If there has, do something. Otherwise, go back to sleep. Power has been conserved. The sleep instruction sends the system into hibernation. So the clear watchdog WT to reset the watchdog timer, then the sleep. So you're going to clear the watchdog timer to begin it at 0 again, then go to sleep. You need to be careful, however, that you place a no-op after the sleep command, so when it comes back out of the sleep, it'll have a 1 clock cycle extra to wake up. The system's going to wake up whenever the watchdog timer times out. We'll talk about how to go about that later. The third major use is a power-up timer. If this function is enabled, if power-up is taking too long, then the CPO will not boot up. It won't allow it to. Very useful in communications. Now, the option register, which is in Bank 1, is register 81, is where a lot of these, the watchdog timer's prescaler is located. Okay, and the prescaler basically is a method of expanding the time that the watchdog timer or timer 0 will have to run. So here's the option register. Notice bit 3 is the prescaler assignment bit. What that does is it will assign either the prescaler to either the TMR0 or the watchdog timer. Has to be assigned to one of them. Also, while we're looking here, notice that the default is watchdog timer has the prescaler and that we have the maximum time set for the prescaler. The defaults are these 1s along the bottom. Bits 2, 1, and 0 are used to set the amount of time of this prescaler. If you're going to start with the assumption that the watchdog timer is assigned to the prescaler, so that means that we'd have PSA bit would be a 1. Now, the watchdog timer operates with a base time of 18 milliseconds. It does not work off of the instruction cycle time that is set by the resonator. It is controlled by an internal RC network. Now, this internal RC network is always powered up even when the system is asleep. It uses a little bit of power, but not much. So here we have, if the PSA is assigned to prescaler, to the watchdog timer, then we have these ratios on the right. Notice that 18 milliseconds is the base time that's due to that RC network, internal RC network. So, taking into account this base time, if we had 1 to 1, it's going to wake up every 18 milliseconds, 1 to 2 every 36 milliseconds, etc. The maximum time for this device, the 84 Alpha, is 2.304 seconds. Again, should be noted again that this is 18 milliseconds is based on the internal RC network. It has nothing to do with the frequency standard set by the resonator. This is necessary because we want it to keep on ticking even when the controller is sleeping, as we saw in the earlier example. Now, just take a second, let's go back and take a look at the TMR0 since we have that choice. Unlike the watchdog timer, the TMR0 timer is based on the instruction cycle set by the resonator. When the controller goes to sleep, TMR0 stops. The TMR0 has interrupt capability, it is maskable, and is presettable. So we'll learn more about the TMR0 later. Back to the watchdog timer, we have to turn the watchdog timer on first, and we have to do that basically before the program starts to run. We do that with a configuration word at the top of the program. As you can see at the bottom, we have the underline config 0x3ff6. Now what this will do, among other things, it will enable the watchdog timer, which is bit 2 of the configuration word. If you enable the watchdog timer and don't do anything else with the prescaler, other than assign the prescaler watchdog timer, or with watchdog timer clears, then so you're not putting any WDT clears, and you're not doing anything else. You're just assigning the watchdog timer to prescaler. If you take the default, which is the maximum prescaler, then it resets every 2.3 seconds. If you don't want this to happen, then what you do is you salt your program with clear WDTs. Make sure you have enough in there so that as long as the program is running correctly, it'll reach a clear WDT before the watchdog timer is set to timeout. So this is about as far as we're going to go with the watchdog timer. We'll cover this in greater detail when we get to the watchdog timer lecture. See you then.